To properly size the branch circuit, short circuit, and ground fault protection, which are often fuses, on our continuous duty single motor, we'll need information found on the motor's nameplate. To start, let's go to Informational Note Figure 430.1, which provides a visual directory of how Article 430 is arranged. The lower half of the figure is set up like a schematic diagram of a motor circuit. Here we see that the requirements for motor branch circuit, short circuit, and ground fault protection are located in Part 4. We scroll up to the top half of the figure and see that Part 4 spans sections 430.51 through 430.58. These sections can be thought of as the bookends, where we'll find the requirements we need somewhere in between. So we navigate to Part 4. Section 430.51 contains the general statement, and we see that 430.52 speaks to what we're looking for. It states that the motor branch circuit, short circuit, and ground fault protective device must do two things. It must be capable of carrying the starting current of the motor, and it must be rated, but not exceed, the value as calculated according to Table 430.52C1, unless otherwise permitted in 430.52C1A or B. C1A states that where the calculated value does not correspond to a standard-sized fuse or breaker found in 240.6, the next higher standard size can be used. This exception is what allows us to overrule the base statement in 430.52C1, which states that the motor branch circuit, short circuit, and ground fault protective device size cannot exceed the calculated value. Next, we go into Table 430.52C1 to find our multiplier. In our example, we'll be using dual-element time delay fuses. For our induction-type squirrel cage motor, we see that the multiplier is 175%. Now that we have our multiplier, we need the ampacity for our calculation. So we go to Section 430.6a to determine whether we should be using the motor table amps or the motor nameplate amps. Based on 430.6a1, we'll be using the table amps to calculate the current ratings of our branch circuit, short circuit, and ground fault protection. The full load amps value found on the motor nameplate is not permitted to be used to size branch circuit, short circuit, and ground fault protection for continuous duty motors. Instead, we'll be using the full load current rating values given in Tables 430.247 through 430.250. Each of these tables applies to a specific motor type. Ours is a three-phase alternating current motor, so we select Table 430.250. We have an induction-type squirrel cage motor, so we focus on those columns of the table. To determine our full load amps, we'll need the horsepower and volts from the nameplate. Our horsepower is 30, and our volts are 460. We locate the 30 horsepower row and the 460 volt column to arrive at 40 amps. Now we have the values we need for our calculation. We take our ampacity from Table 430.250, which is 40 amps, multiply by 175%, from Table 430.52C1, and get 70 amps as our minimum calculated rating. Next, we go to Table 240.6a to determine if 70 amps is a standard fuse size. When looking at Table 240.6a, we see that 70 amps is a standard size fuse. We should note here that if the calculation came out to be less than a standard size, say 68.7, then 430.52C1a would allow us to round up to the next higher standard size and choose the 70 amp fuse. Our calculation came out to be a standard size, so there is no need to round up. However, let's say we installed the 70 amp dual element time delay fuses, but they did not hold during startup. What next? Let's revisit 430.52C1 to find out. Where the rating is not sufficient for the starting current of the motor, 430.52C1B2 is specific to dual-element time delay fuses and allows us to increase our multiplier from 175% to 225%. We multiply 40 amps by 225%, which results in our calculated value of 90 amps. In this case, the calculated value would be the maximum, so if it does not correspond to a standard size in Table 240.6a, we would have to round down. We go back to Table 240.6a and see that 90 amps is indeed a standard size, so there is no need to round down. In the case of our previously selected 70 amp joule element time delay fuses not holding during startup, we can use 90 amp fuses for the branch circuit short circuit and ground fault protection on our single motor.